record.
Now I will record. Okay. So I open the whiteboard. Okay, question number 3. It says that an employer wishes to hire 3 people from a group of 15 applicants, 8 men and 7 women. 8 men, 7 women, total 15. They want to hire or so-called select 3. Then all of them are equally qualified to fill the position. If he selects the 3 at random, what is the probability that all 3 will be men? Number 1, we want to know that all 3 are men. Okay. So we say that let A or E is an event that we select 3 men. So first of all, we define sample space. Out of 15, out of total number of applicants, we are selecting 3. So it will be 15C3. Next is we are interested in men. So all 3 are men. So in that case, number of all possible outcomes, I can write here, number of all possible outcomes of the event A. Anybody is waiting in the waiting area? Yeah, Jonathan is waiting. So N of A, we want to select 3 men and there are 8 men in total. So it will be 8C3. So the probability that all 3 will be men, 8C3, and in total how many people we want to select? We want to select 3 people and remaining, there is no one remaining, so 0 woman will occur. So it is 15C3. Even if you can leave it like this, that is fine, no problem from exam point of view.
Hello?
Yeah, I was offline, bad internet connection, sorry. So can you see my share screen now?
No.
Okay. How about now?
Yeah.
Okay. So the second part is, it says that at least one will be woman. In second part, it says at least one will be woman. At least one will be woman means to say that we define that let B is the event that at least one woman will occur. So N of B, one woman. In total, how many people we want to select?
3.
3. And there must be one woman. We say that if we select one woman, so remaining 2 will be men. Is that clear?
Yes.
Or the second option could be at least one woman, there could be 2 women. If we select 2 women, then remaining one will come from men, because in total we want to select 3 people. In total, we want to select 3 people. 2 plus 1, 3. 1 plus 2, 3. Understand? Out of 15 people, 7 plus 15. 7 plus 15. Out of 15, we want to select 3 people. And what is the condition? At least one will be women. If one is women, then remaining 2 will be men. Can you follow the pointer of my pen?
Yeah.
Okay. So here you can see that the 2, if 2 are men.
Where's the pointer?
No. No.
Can you see the pointer now?
No.
Okay. Then I will point, then I will write it, for example. And then the third option, at least one woman means all 3 will be women, then we will not have any men. Is that clear?
Yeah.
Any
Yes.
question? So the probability will be, probability of event B is 7C1, 8C2, 7C2, 8C1, 7C3, 8C0 divided by 15C3. Now I change this problem. I change this problem and I generate another problem, and I say at most 2 men. At most 2 men. It means there could be no men, there could be 1 man, and there could be 2 men, but not more than 2. At most means maximum we can select 2 men. Is that clear? So I define an if
Yeah.
let C is the event that at most 2 are men. That at most 2 are men. So won't select any men out of 8. We will not select any person. So it means all 3 will be girls, because we will need to select 3 people. The second option could be if we select 1 man, then remaining 2 will come from women. And if we select at most 2 men, then remaining 1 will be women. So its probability is 8C0, 7C3, 8C1, 7C2, 8C2, 7C1 over 15C3. Is that clear?
Yes.
Yes.
Now let me modify it into another problem. We say that if we select less women than men. Then let E is an event that we select less women than men. In that case, N of E, less women. It means that if we select 0 women, we will select 8 men. Men are more than women. Second option could be if we select 1 woman, we will select 2 men. So we don't have any other option because we want to know that men are more than women. Understand?
Yes.
So the probability is 7C0, 8C3, 7C1, 8C2 over 15C3.
Wait, I cannot see anything.
Why?
Let's see.
Now
Oh, now it. Yeah.
I just move them up.
Oh, okay. Okay. Sorry.
Okay, so I tried to modify another problem. Let's say uh, another part. Say that what is the probability that we select 4 men and 1. Who can tell me? And the second one is what is the probability to select 9 men? Who can answer me? I can open the room and I can see who is going to answer. Let's say who is at the top, Christine in the list. Okay, Christine. What would be the answer for this?
Probably that we select 4 men and 1 woman.
What is the probability that we select 4 men and 1 woman?
From the previous question, like the
Yes, we are discussing the same question.
same 7C.
Here it is. Can you still see?
Yeah.
Okay. Now
4 men, so 8C4 times 4 men and 1C7.
7C1, not 1C7. You said 1C7.
1 woman.
It means that we are selecting 7 people out of 1. Does it make sense? Always
no.
bigger number comes here. Always bigger number comes at the top of C and lower number comes here. Maximum they can be equal, but they cannot be in a other order like denominator. This number cannot be greater than this number. It we read it, we are selecting 1 people out of 7. We are selecting 1 people out of 7. If we write 1C7, we say that we are selecting 7 people out of 1. This is impossible. Now,
Okay, so 7 1 over 15.
so how many people are you selecting in that case? How many people are you selecting in that case?
One of 4 men and 1 woman, so 5.
So, and how many we are asked to select in example 3?
In example 3, we are asked 3.
3. So how many people we are selecting here?
In which one? The one that you just asked me?
This one.
We're selecting 5.
Yeah, so this is a valid question. This is a valid question. If you say that now we are selecting 5 people, then whatever you said, that is absolutely correct. But if we consider it with reference to this problem, then you can say that, okay, since we are asked to select 3 people, but here we are selecting 5 people, so that is not possible. And who can, very good, you are right. I will not say you are wrong, you are absolutely right. Now how about this number 5? Who can answer this number 5 with reference to this problem?
You cannot. You cannot answer because there is only 8 men, but you're asking 9 men.
Yes, very good. Very good. Who said this?
Chandra.
Very good. We cannot select 9 men because we have only 8 people in the group. Okay. So any other question, please? Any other question? Any other question from this PPT? Okay, no question. So the next is very important. If 2 events A and B are not mutually exclusive, then the probability that at least one of them occurs is given by the sum of the separate probabilities of events A and B minus the probability of the joint event A intersection B. Means to say that if they are not mutually exclusive, means if they can occur together, in that case, we will subtract their probabilities. We will subtract their joint probabilities. I can explain this concept with a simple example. Let's say we deal with an example. You toss a die. You toss a die. You toss a die 2 times. We say that what is the probability of getting some 8 or even number? or let's say what is the probability of getting sum 8, or let's say what is the probability of getting sum 7 or double numbers. Do you understand the problem? Everybody understands the problem? Please tell me.
Yeah.
Yep.
You used to say that you toss a pair of die, and what is the probability you get the sum equals to 7 or a double number? We say that its solution is we say that let A is the event that we get double number, we get number 7 or and let B is the event that we get a double number. Now we list down all the possibilities of getting a 7. If we get 6 on the first die and 1 on the second die, then sum is 7. Understand?
Yeah.
Yep.
If we get 5 on the first die and 2 on the second, keep increasing this first one, keep decreasing this first number and keep increasing this second number, you will get the all options. If we get 4 on the first die and 2 on the second die, then still and 3 on the second die, still sum is 7. If we get 3 on the first die, 4 on the second die, still sum is 7. Likewise, if we get 2 on the first die, 5 on the second die, still sum is 7, and likewise 1 and 6. So these are all possible options for A. Now we define event B. What are the possible options in event B? Event B, it says a double number, a double number. How we can get double number? If we get 1 on the first and 1 on the second, or we can get 2 on the first and 2 on the second, or we can get 3 on the first and 3 on the second die, or we get 4 on the first and 4 on the second, or we get 5 on the first and 5 on the second. Likewise, 6 on the first and 6 on the second. So is there any point in common between A and B? Is there any common point? So it is 0, we can say empty set. There is no point in common between A and B. So they are mutually exclusive. They cannot occur together. When they are mutually exclusive, in that case, we will use this second formula. Probability of A union B equals to P of A plus P of B. So probability of A union B means probability of event A and probability of event B. Probability of event A is how many possible options in A? What is N of A? N of A is 1, 2, 3, 4, 5, 6. 6. So probability of A is N of A over total sample space plus N of B over n of s. There are 6 elements in A, and in total sample space have 36 elements. We have discussed yesterday. Similarly, n of B, how many elements in n of B? 1, 2, 3, 4, 5, 6. So n of B is also 6. So 6 over 36, which is 12 over 36, which is 1 by 3. So that is probability of A union B. Any question?
Well, didn't you say that these two cannot happen because there's no probability of the same numbers? I'm confused what the question is asked.
Ask me the question, no problem. Don't get confused. Ask me.
Yeah, I don't understand what the question is asking.
This question? This question you mean?
Yes.
It is asking you that you have a pair of dice. You roll them, and what are the chances? Either you get sum equals to 7 because you are rolling 2 pair of dice. You can get some numbers on the first die, you can get some number on the second, and that sum would be 7. In that case, if you roll 2 pair of dice, if you get 6 on the first and there must be 1 on the second, then sum would be 7. This is the first option. This is the first possibility you can get sum equals to 7 like this. Then the second option could be you can get 5 on the first and 2 on the second. That is the second possibility to get sum equals to 7 on the pair of dice, the number which appears on the top. Is that clear? So we list down all the possibilities which gives us sum equals to 7, and then it says or double number. When you roll or toss a pair of dice, you should get a double number. How can you get a double number? If you get 1 on the first and 1 on the second die. Likewise, if
Okay,
you...
I understand now.
Okay, good. So now I change this problem and I say that I need your attention and you need to observe what is the change. If I say you toss a die 2 times, what is the probability of getting sum equals to 8? I just change it to the sum equals to 8 or a double number. Again, in that case, we say that let A is the event of getting sum equals to 8, that n of A, or first we write this set A, sum equals to 8. If we get 6 on the first die, then 2 should be on the second. If we get 5 on the first, 3 on the second, 4 on the first and 4 on the second, 3 on the first, 5 on the second, and 2 on the first, 6 on the second. That is n of B. And then again the rest part was same. Let B is the event of getting double number. So double number would be 1 1 2 2 3 3 4 4 5 5 and 6 6. Is there any point in common between A and B? Is there any point in common between set A and B?
4, 4.
4, 4. So, how many elements in A intersection B? There is only one element. Similarly, n of A, number of elements in A are 6. N of B equals to 6. So again, now this is not
It's for A, it's not 6.
sorry for
For A, it's not 6.
1, 2, 3, 4, 5. Very good. It is 5. This is not mutually exclusive because A and B can occur together. See, 4, 4 is satisfying the both properties. 4, 4 is a double number and sum of 4, 4 is 8. So this is not mutually exclusive. Then we will use this formula. Probability of A union B equals to probability of A plus probability of B minus their common probability. Probability of A is total number of elements in A divided by total number of elements in the sample space plus total number of elements in B over total number of elements in sample space minus total number of element in A intersection B over total number of elements in sample space. So n of A is 5, sample space is 36, n of B is 6, sample space is 36 minus how many elements in n of A intersection B is 1. So it is 1 by 36, which is 36, 5 plus 6 minus 1, 10, 26 by 36. So that is probability of A intersection B. Is that clear?
Why is it 26?
Oh, yes. It is not 26. 10 by 36. Any question? Any question?
This is very good when playing Yahtzee.
Sorry?
It's very good when playing Yahtzee, you know, with dices, you throw them.
Yeah.
No,
Sir,
no questions.
sir, so I have a question. This is,
Wait, Chanda. Let me clear with
yeah.
Chris.
Okay.
Yeah. Carolina, sorry. You
Also, can I?
before who was asking me? Carolina?
Yeah, but I didn't have a question.
No.
I just need to practice on
Okay.
this one.
Okay. Then Chandra.
Oh, so we only use this method for mutually exclusive problems, right? Not, okay.
Yeah. Means we will subtract this one. We will subtract this one when we have not mutually exclusive events. For example, I solve one more example. Let's say you have a set of numbers from 1 to 100. Your sample space is, total numbers are 1, 2, 3 up till 100. What is the probability that number is either divisible by 4 or 6? What is the probability that the number is divisible by 4 or 6? So we define an event. Let A is the event that number is divisible by 4. So how many numbers are divisible by 4 from set of 100 numbers? You can divide 100 by 4. There are 25 numbers like 4, 8, 12, 16, 96 and 100. I know there are 25 numbers which are divisible by 4. How do I know? I can simply divide 100 by 4. It is 25. So there are 25 numbers which are divisible by 4. Is that clear?
Yes.
Okay. Now the next is let B is the event that number is divisible by 8. So we can write 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96, and so on. Now, event A or B are mutually exclusive or not? Is there any point in common between A and B? Yes. A.
Okay.
All B is common. 16, 24, 32, 40, 48, 56, 64, 70, 80, 88, 96. So this is all which is between A and B is common. So the probability is A intersection B is probability of A plus probability of B minus probability.
Why,
Yeah.
why isn't it 100? Can it not be 100? It's only between.
But 100 cannot be divisible by 8. It is divisible by 90. It is divisible by 4, but not by 8.
Yeah, but in B. Or, I mean A. Oh, I don't know.
In 8.
But in 4, it works.
No. In 4 we have 100. It works. But with 8, 100 is not divisible by 8, so we don't have 100
No.
in B. What is your question? Did I answer?
Yeah, but the second one, you only went Yeah, in the second one,
What do you mean
you
by,
wrote
please, can you read it? A intersection B or N of B?
A and B. It's only until 96.
Yeah, because what are the points in common between A and B,
Oh, yes, I understand.
right?
Yeah,
8 is in A, so 8 is,
yes, yes,
16 is in A, so 16 is common.
yes.
24 is in A, 24 is in common. Up
Yeah.
till this 96 in A, 96 is common, but we don't have 100 in B. So it is not common between A and B, so we don't write 100 here.
Yeah, got it. Thank you.
Good. So probability of A is N of A over N of sample space. Sample space means total 100 numbers. N of B over N of S minus N of A intersection B over N of S. So N of A, in A we have 25 elements over 100 elements. In N of B we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In N of B I have 12 elements over 100 minus in A intersection B I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N of A intersection B is also 12. So it is 12 by 100. So this number will cancel out with this. So the probability is 25 by 100, which is 1 by 4. Probability of A intersection B is 1 by 4. Is that clear?
Yeah.
Sir, I have a question. Can we use like the NCR method to solve this question, or the NCR only for the mutually exclusive questions?
NCR. We cannot apply NCR for coins and die,
Oh, okay.
because
Okay, got it.
for coin total number of possibilities can be 2 raised to power n. If you toss a coin once, total number of possibilities are 2. 2 raised to power 1, head or tail. If you toss a coin 4 times, total number of possibilities would be 16. If you toss a coin 5 times, total number of possibilities would be 32. And similarly for die, total number of possibilities are 6 raised to power n. If you toss it once, you have 6 possibilities. 1, 2, 3, 4, 5, 6. If you toss it 2 times, then total number of possibilities are 36. Similarly, if you toss it 3 times, total number of possibilities are 216, and it continues. But in case of cards or any other problem, we use combination. Similarly here, this problem was related to counting. We were given, why do we use combination? We use combination in order to know sample space. We use combination in order to know the sample space, but here in counting problem, we are already given sample space that we have numbers from 1 to 100. That is our sample space. So N of S, total number of elements in sample space are 100. We don't need to use combinations because we are already given our sample space.
Okay. Yeah, thanks.
Welcome. So for example, here if a card is selected at random from a deck of 52 playing cards, what is the probability that the card is club or a face card? This is, you can omit this one or both. Now we solve this example and we see is it mutually exclusive or not. If one card is selected at random from a deck of 52 playing cards, first of all, your sample space would be, there are 52 cards, we are selecting one. So sample space is 52C1. What is the probability that the card is clubbed? We say that let A is the event that card is clubbed. So how many clubs in total? 13. So 13C1 is 13. Understand?
Yeah.
And the next is or a face card.
No, wait.
Yes,
Club.
yes.
What is face card is king and dose. So
Queen.
wouldn't it be 10 for club?
No.
What is club?
Club, there are,
This is 13.
there are in total.
I'm in hearts.
Oh, thank you, Christine. Yes, got it.
What did you got?
She answered my question.
What did she answer, which I cannot?
No, I just didn't know what card was, and yeah, and she answered.
Yeah. So we are interested that the selected card is club, right? What is the probability that the card is the club or a face card? Then we say that let B is the event that selected card is a face card. So how many face cards do we have? There are 12 face cards, so it is 12C1. Now a club and a face card, are they mutually exclusive?
No.
Why not?
Because there is a club on.
No, I don't think.
Yeah, there have clubs on a face card, like a king.
They can occur at the same time.
Who is saying no? Who is explaining, by the way? Crystal?
Hmm?
Christine?
Yes?
Who was
Yeah.
explaining this just now?
Yeah, me and
Both of
Christine.
us.
Okay, both of you are correct. Very good. One number for each. 1 point for each, Christine and Crystal.
Oh, thank you.
Yeah, do remind me in the final exam. Very good. They are not mutually exclusive because a face card also has a club. Now, I ask you one more question. Who will answer me first? He will get 1 point. How many cards are common between A and B? If they are not mutually exclusive, which are actually. So if they are not mutually exclusive, then how many points are in common between them? Whoever will answer me first, he will get 1 point.
3.
You said, Tiffany?
Me, Tiffany.
Okay, Tiffany, I can listen to you, please. Won't be too loud. You got 1 point. Do tell me. Is that clear to everybody why it is 3? Now Tiffany, explain it to them. Why there are 3 cards in common. Tiffany, where are you?
Oh, hi. Because
Yeah, tell them.
every what's the thing called when you call it club and hearts and clover and diamond? Is it clover? Club? No, that's club. No, that's yeah. What is that called? The 13 cards. What does that? I don't understand how to explain that.
Okay, I explain it. See, uh, every card has 4 possibilities. Like king has 4 cards of all different categories: king of club, king of spade, king of jack, and king of diamond. So king of club is one possibility they can occur together. Jack of club is the second possibility they can occur together, and queen of club is the third possibility they can occur together, because we were interested to find out the probability that the card should be a face card or a club. So there are 3 points in common between A and B. Is that clear to everybody? This is very important to understand, because in your examples would be exactly same, just a little change. I have already given you this assignment in the last tutorial that you were supposed to convert these 4 problems into 8 by changing them on your own. I will change same problems but a little difference in your exam, and you would not be able to solve it unless you understand them clearly. So is that clear to everybody? So the points in common between A and B is 3. So the probability of A union B is probability of A plus probability of B minus probability of A intersection B. So probability of A, number of elements in A, n of A over n of S, then n of B over n of S minus n of A intersection B over n of S. So it is 13 over 52 plus 12 over 52 minus 3 over 52. Is that clear? Which is 52 over 13, 12 minus 3, which is 22 over 52. That is probability of A union B. Is that clear to everybody?
Yes.
Is that clear?
Yeah.
Okay. So that was the question number 1. Question number 2, I have solved it in a different way. Here he is asking, an integer is chosen at random from the first 200 positive integers. What is the probability that the integer chosen is divisible by 6 or 8? You will do it on your own, because I did one for 4 and 8. I have solved one example exactly like this, and you will solve one with 6 or 8. Is that clear?
Yes.
And the next one, a pair of dice are thrown, find the probability of getting a total of either 5 or 11. 5 or 11. Is it mutually exclusive or not mutually exclusive? Is it a mutually exclusive event or not?
It's mutually exclusive.
Yes, they cannot occur together. Very good. So that is it. next is conditional probability, but I don't want to cover this because we don't have enough time, and also it is a bit confusing, and it would be very confusing for you to cover it in such a short span. And I want to cover the next topic as well. So if you have any question, and now listen. Now, what is your assignment? How many assignments do you have right now, including the last one?
7.
7. This is your 8th assignment. I gave you one assignment yesterday. Did you finish it?
Yeah.
Okay, good. So if you have any question about that assignment, you can put it now. One thing more, you can see 3 problems here, okay? I will try to post some more problems within this week. Otherwise, you have 3 problems. You will convert them into 9. You will convert them into 9, and I will convert them into 9 as well. And then I will post all together. I will post 20 problems, including the 12 from the first one and 9 from this. That would be your assignment number 8. And this probability is very hard topic. I'm not covering all. I just covered the simple section so that it would be easy for you to get the basic idea of probability. I'm not touching the hard one, and because it is not easy to explain it in such a short span, we need at least 2 or 3 lectures to cover that. So you know, we had a small semester in this unusual situation, and if we would have 4 months to study, then we can easily give 3 to 4 lectures, and you can convert these 3 problems into 9. And next week we will discuss the last topic, and week after we have exam. Is that clear?
This is the last topic, or the second to last, you
This is
said?
this is second last. This is second last topic. Next week I will cover the last topic, which is very simple, which is very easy, no problem about that. So, and week after, when did we decide the final exam? 27th or 28th?
28.
28th. Okay. So on 28th we have exam. So if you have any question, you can go ahead. Otherwise, we can stop it here.
Sir, I have a question. I'm so sorry for the last minute question, but I couldn't hear what's the differences between face card and club card. Can you repeat it again and explain why 3 is
You can ask me anytime. Don't say that you are sorry and asking the question last minute. We always welcome your questions. Listen, can you repeat your question once, please, so that other can listen it as well?
Yes. Okay. So I don't understand the club card and face card thing. I mean, I already bought the car yesterday, so I was looking it through so I could understand better, but I don't know, I've never heard of face card or club card. So can you explain it again?
Okay. Can you see my screen?
Yeah.
There are 52 cards in total.
Mm-hmm.
26 black, 26 red, right? Now,
Yeah.
these 26 have further categories. 13 have this image on them. 13 have this image. which you all of them very familiar. 13 have this image. Understand? Image means a sign, not image in fact. And 13 has
Yeah.
sign like this. Okay? This sign is called diamond. This sign is called, you know, what is this? I made it beautiful.
Heart.
I make it beautiful. Okay, this is for you. Heart. This is called spade. And this is called, I'm not sure about their names, but the signs are exactly same. So we have 13 diamonds, we have 13 hearts, we have 13 spade, and we have 13 club. Is that clear?
Oh, yeah.
Okay. Now, after this, we have a card with number 2. We have card with number 2, and this card number 2 have 4 cards in total. We have 2 of diamond, we have 2 of heart, we have 2 of spade, and we have 2 of club. Understand? So in total we have 4 cards with number 2, and all those 4 cards have different signs, one with diamond, one with heart, one with spade, one with club. Is that clear?
Yeah, but there's no number 1. Is it ace?
Yeah, that is ace.
Yeah.
That is ace.
Oh, okay.
That is ace. We have A of diamond, we have A of heart, we have A of club, and we have A of spade. Similarly, we have number 3 with all these 4 categories. So 4 cards for 3, 3 of diamond, 3 of heart, 3 of spade, and 3 of club. Is that clear? So similarly, we have for 4, we have for 5, 6, 7, 8, 9, 10. And similarly, we have for jack. Jack has image on that, right? Jack of diamond,
Yeah.
jack of heart. Similarly, jack of spade and jack of club. Understand? We have 4 cards for this, and similarly for king, we have king of diamond, king of heart, king of club, and king of spade. Understand?
Yeah.
That clear? And similarly for queen, we have queen of diamond, we have queen of heart, we have queen of spade, and we have queen of club. Now the question was, what is the probability that you get a diamond or a face card? Now how many diamonds in total we have? We have total diamond 13, and a face card, there are 3 face cards, jack, king, and queen. Understand? Now these jack, king, and queen, sorry, we have 12 cards. We have 12 cards with picture. King, queen, and jack, all 3 cards have picture on them. In total, they are 12. And out of these 12, we have king of diamond, queen of diamond, queen of diamond, and jack of diamond. They are not mutually exclusive, which is satisfying both properties. We are selecting a card with diamond and we are selecting a card with face. So that is why 3 is common between these two events. I hope it is clear now.
Yeah. So Jack and King and Queen, they are all face cards, right? They are all face cards.
Yeah, king, queen, and jack, all of them are face card, or sometimes we call them a picture card. Is that clear?
Okay.
Any
Yeah.
other question?
Mm-hmm. Yeah.
If you have any other question, just go ahead. This is lecture 8. I think so. Okay, then I stop the recording.